Hello learners, we already discussed about what is the storage management in programming. So later we discuss heap storage management. I already discussed one of others storage management. So what is heap? Whenever you start programming in any languages like C++, C, Java, so they need some space. Compiler want to execute the programming code. For that, we require some kind of memory. That memory is fulfilled by the main memory from the RAM. What is the division? What the reason behind we require that memory as much as the programming code, the programming data required for that execution. Whenever we start this compilation part, we first checking what kind of the structure our programming code required. Then we allocated some part of that, like there are classes, there are method, there are functions, there are data types. All that type of structure of a program, we require some space for them also. So we required the storage. And this storage is completely required at the compiler time. So we start to learn what the heap type of storage management and what is the importance of that. I already briefed these type of storage heap. I already briefed to you in previous class, but we also learned much more about that in this lecture. So the heap storage, it is fulfilled by the main memory, by the RAM. Whenever any programming code required any memory storage in the main memory, they fulfill the requirement according to the code. But there are two type of space we can maintain for that code. One is fixed and other one is variable. We already know what is variable. Variable is the data, the value of that code may vary. So it is not fixed at the compiler time. We already discussed some of the storage management we required whenever we declare in compilation time. We also change that on the dynamic way we can change at the runtime. But in heap, we can manipulate at fixed size, also variable size. So there is no much criteria, much restriction to decide on the compilation time or the runtime. We can moderate our situation according to our requirement. If we require some fixed value, some fixed memory, then we use fixed site heap management. Other than we can change our values, our storage management, we can switch to the variable size heap storage. After this lecture, we learn about the heap storage. There are two types: fixed size heap storage, variable size heap storage, and we also can differ these two terms in this lecture. Start from what is the we expected learning. So already discussed. We have another other part of storage management, heap storage management. It have two other features. One is fixed size and other is variable size. Okay. So there is just some allocation in main memory. Here a diagram showing in the right of this PPT. So there are many, it is kind of memory space. It is look like a space area whenever some of the memory is fulfilled from any of the program. But there are some memory are free. These free memory called as heap. But how we can allocate, how we can plan to use this free memory with the help of our storage management, and this storage management called as heap storage management. It is a memory management technique. What is it? It is a memory management technique which can be learned how any kind of requirement of storage in any memory through the any technique are maintained by memory management. So language to allocate and deallocate. Whenever we required any space in the memory, we say this is the allocation of that memory. Whenever we deallocate, we free these kind of memory after execution of our program. We call this a deallocation of memory. It is done by the dynamically at the runtime. Whenever we see this term dynamically, it's mean it can be done at the runtime. So heap storage management allows for memory to be allocated and deallocated dynamically, means at a runtime. In heap storage management, a memory block is allocated from a pool of available memory. Whenever we know about the what is the pool of memory, all the free memory, all the free memory in our main memory can be called as a pool of available memory. Heap storage management provide flexibility in memory allocation. It is not just fixed. We can vary according to our choices. So there are we have many chances whenever our program required more memory, it can be changed through the variable size memory. And if we require fixed type of memory, we can choose fixed storage type of heap storage management. So we have options for both. If we require fixed size of memory, we go with the fixed size heap storage management. If we required variable size, our memory requirement can be changed through the program. So we go with the variable size heap storage management. Heap storage management can also lead by the memory fragmentation. There is new word fragmentation. Fragmentation, just think we have a box, we have a bottle, and we fill some of these bottle from water. After that, we just put any cover on that. So there are many space in that bottle are not filled. But when we deallocate, refill this bottle, we just put it down and we just completely out water from that bottle, that whenever we refill this, so it can take some of space for the bottle, the remaining a little water in that bottle, it is called a fragment. When we use any memory, there are some space are not used for their programming, and these area are not usable by other program. So this bad area, it is not used by any program, any process, are called as a fragment memory. Whenever we use any storage management in our programming, we required memory at a time. So we just fill out the memory part one after one. But whenever we deallocate the previous one memory and new one memory space, there may be some space are not used by any program, and these space are totally wastage. To minimize these wastage space, we use heap storage management. So it is best for memory fragmentation. Memory fragmentation occurs when small block of memory are allocated and deallocated repeatedly, leaving behind small unusable chunks. So these unusable small spaces called chunks of memory that cannot be used for further allocation, and therefore our that part of memory is totally wasted. Heap storage is a memory management technique that allocate and reallocate object dynamically during the runtime. there will be any functions, any methods. So whenever we require any memory part for any functions, any object, so it is totally done on that runtime. In OOPS, object-oriented programming, fixed and variable size heap storage management concepts are typically implemented in the memory allocation strategy. So whenever we use these runtime space by the operator, new operator, it is used for required a certain amount of memory request from the heap. Heap is the free memory spaces in the main memory. Heap storage management is a dynamic memory allocation technique used in the programming language to manage memory at the runtime. All these features, like what is the properties of heap storage management? It is totally allocate memory at runtime. It is not structured memory, it is a unstructured. There will be a memory fragmentation. The small chunks, small memory spaces are repeatedly used, and after that they deallocate, and the space are blank, are not using by any other functions, any other object. Overhead, security vulnerabilities, dynamic memory allocations, unstructured memory. These the memory leaks, all these the properties of a storage management. You already these spaces we learn, so it is not need to define each and every time, but some of that part. Okay, I just read out all these. Okay. Fixed size heap storage management is often used for object for a fixed size, such as those created from a class with a fixed number of data members. The memory allocation size can be determined at a compile time and allocated as a fixed memory block for each block. So already we discussed about this. Whenever we need to move for the variable size, we can use array for that. Fixed size heap storage management is a method of allocating and deallocating memory in a program where the size of heap is fixed at compile time. So whenever we require fixed size of memory, that means we have the objects, the functions that are totally completed with the required spaces that is done at the compile time. All these languages are used dynamically, means runtime allocation for the storage. What is the applications? They use these fixed size heap storage. What kind of systems are using like these languages, these heap size storage management in their programming? That are called embedded systems, real-time systems, database management systems, game development. Whenever we require this kind of application, we need to use these heap storage management. Also, in the image processing, in computer vision, with the dynamic data structure like linked list, when you learn about the data structure, there are some kind of terms, linked list, binary tree, and hash tables. They use fixed size heap storage management. Complex algorithms such as sorting and graph algorithm also fulfill through the heap storage management applications that require large amount of memory. Whenever you need maximum memory, that means you require heap size storage management. What is the advantage of using fixed size heap storage management? We already know what amount of memory we required so that we can predict memory use, reduce memory fragmentation. We don't waste our repeatedly uses memory to avoid fragmentation. Easier memory management. We can manage every part of the memory required by the any storage class, any objects, any functions, any variables. So we easily maintain that, and we also minimize the risk of memory leaks. Memory leaks means the wastage memory. So already, what is the disadvantage? Whenever we use fixed size, the wastage memory, limited flexibility, difficulty in managing memory usage, inefficient memory use, increased complexity. These are the drawback of fixed size heap storage.
Variable size heap storage management allocate and deallocate memory in a program where the heap size changes during runtime. Whenever we can change our requirement of memory, so we require variable size heap storage for that class, that storage. In programming C, variable size heap storage management is implemented using the malloc. There are talloc and malloc. Some functions are used to allocate memory space in any programming language. There are functions are different. Whenever we required in C, we use malloc function for allocation memory and free function for deallocation memory. So there are two methods for allocation of memory. We use malloc function, and whenever we need to deallocate memory, we use free function. The malloc function is used to allocate a block of memory of a specified size, and the free function is used to deallocate the block of memory. What is the applications of fixed size heap storage management? Variable size heap storage management. One of them are operating system. Operating system, we all know, with the help of operating system, we can interact with the system, all kind of the functions of any system we can use, like programming, like video streaming, any kind of work we go through with the help of operating system. That also called a system software. We need to develop many websites with the help of operating system, with the help of these programming language. There also use of scientific computing. There also use in AI and machine learning of these variable size heap storage management, video and audio processing. These all terms required more spaces, more memory. Whenever we complete this kind of execution of programming, we require more memory. And whenever we require more memory, we directly need to go with the variable size storage management. So all these areas, all these applications are just done with the help of applications of variable size heap storage management. What is the advantage? There will be flexibility of using any memory space in that. The efficiency also be increased whenever we require any memory part in the given time, so that the efficient work of that programming also be done. Memory reuse, we can reuse the memory part. It can be repeatedly used. Reduce memory wastage. There are fragmentation part also not required. Improved performance. Whenever we required any type of memory, when we required any completion work done by the any memory part, so that whenever any application, any program done with the help of all the resources like memory, space, time, that means it also improve the performance of that system, that application. What is the disadvantages? So all these non-deterministic behavior security vulnerability, it is not required at all, but just you need to know what is the benefits of any kind of these storage management and what is the vulnerabilities, what is the negative part of that storage management. But you just need to know what is kind of memory storage management are using in any programming languages. So we are learning all these programming storage management. There is comparison between fixed and variable size heap storage management. So very main difference between fixed and variable size heap storage management is how they use their memory for allocation part and the deallocation part. So all these are comparison, just differentiate them for their use. It is not totally there is much bigger differences on that. It is part of heap management. Heap management is completely done by fixed and variable size heap storage management. When we know what the required memory part, then we go with the fixed size heap storage management. Whenever we don't know what kind of memory spaces we require, the memory requirement is varying by the time, then we go with the variable size heap storage management. So the memory is typically divided into fixed size chunks or blocks, which are then used to store data as needed by the program. Variable size heap storage management, on the other hand, allows programmer to allocate and deallocate memory of varying size as needed. Whenever they require, the size of the memory requirement is changes at the programming time, at the working time, at the execution time, at the runtime. So we go with the variable size heap storage management. Memory is typically allocated from a contiguous block of memory known as the heap. Whenever we require, we fulfill these kind of memory spaces. Already we can see the first slide of this lecture PPT. So there is a diagram. So allocation memory and the deallocated heap area there will be mentioned. And these heap area is continuous block of memory known as a heap. Fixed size heap storage provide predictable memory uses but can be wasteful and inflexible, while variable size heap storage provide flexibility and improved efficiency. This also improve the performance of that system. So this is small part of that last lecture we conclude in this session. We need to complete another PPT. So just wait. I'll just share these also. Just a second. Okay. This other topic for today's lecture is introductions of parallel processing and programming languages. What is parallel processing? What is serial processing and parallel processing? It is very useful topic nowadays we are using in our programming. It's simply when we do multiple tasks at a time, so that means our programming, our working scenarios change. In 90s, in 20s, in 21st century, there are many systems are we use. Starting days in the Windows XP time, there our system has some limitations, which means they can complete one task at a time. But the byte at that time, there are multi-core system, multi-threaded system are implemented. These devices complete up their working with the help of parallel processing. So whenever we complete these kind of work with the help of parallel processing, that means the production of that system is higher than the serial processing part. Serial means one by one in like row. Whenever we have five processes, five paper, which means first we complete one paper, then second paper, and third paper, and fourth paper. If we done these five papers simultaneously, which means at that time we can complete five of the paper. It's not completed means that subtopic. 1 second. Sorry for the, okay. What we predict after completing this unit, we can understand what the concept of parallel processing, what is the various challenges faced by the parallel processing, and how we can achieve all kind of this processing by the help of parallel processing, and what the programming languages used for parallel processing. So after this lecture, we can know what is the parallel processing and what the challenges. What is the parallel processing? Parallel processing is simultaneous execution of multiple tasks. I already briefed you all about that. We have multiple tasks. We can start the Zoom session with the, at that time we learn some other task in the like in gaming, the like reading, like any access of other websites. So that means there are many applications are running at a time, and it is done through the parallel processing. There is multiple task or processing using multiple processor. We have multiple processor also for that kind of application, that kind of processing. These approach to computing has become increasingly important as the demand of computer system grow and the need of more processing power and faster data processing become critical. By the time our requirement is become vital, and we require more processing at the time. We require minimum time to complete any task. We need to performance our system. When we click on that system, we just open that kind of application. When we start any task, it's just complete at that time. We don't have much time to complete the task. So we require other than multiple processing that called a parallel processing. Parallel processing, whenever we need know what is the multiprocessor. Multiprocessor which means we have multiple processor in that system to complete their task. It is not done by one computer, one processor. We always think what is the most important part of any computer system. There is only one, which is called as processor. All other parts of that system are just helping hand of the processor. All the work done through the processor, not by any other part of your computer. But we required some interface part to inputting some elements like our instructions in given way. It is not done just we taking without care of any instruction format and just putting any limits on that system. It is not fulfilled. Whenever we can complete our requirement, our instruction in given way, in prescribed way, that called as a inputting. And after that, the output part, the system is just generating the signal. There are 0 and 1, but by the time we have other softwares, other kind of application that may help us to improve the use, the kind of application, how they perform, how they conclude, how they product. The key advantage of parallel processing is improved performance. It's totally agree with that term. When we complete many tasks at a time, in given time, in prescribed time, that means the performance of the system may be improved and faster data processing. Also, done the processing part of any processing very fast way by breaking down complex tasks into smaller sub-tasks that can be executed simultaneously. Parallel processing can significantly reduce the time required to complete a computation of data processing. We already discussed these kind of work. The principle of parallel processing at the features and capabilities of programming languages, one can create more efficient and effective software system. So by the help of parallel processing, we can make like supercomputers, like mainframe computers. They can do very efficient and effective software systems. They can use it like meteorological department, like defense systems, like science and technology part that need to complete in efficient and effective way. So there is a mesh, one have sender and other one is receiver. And that time, if we send only one instruction at a time, that called serial processing. But in this image, we can complete many instructions at a time, that called parallel processing. It is just simple program. It is not done like that, but in the receiver system, there have a multiple processor. In the center system, there are multiple processor. There are multiple process in the line, and one process done by one processor, second process done by second processor. So there are 6 applications done by 6 processor. Maybe the processor may have multi-threaded, multi-core also done these at a time, but not completed at once. Parallel processing is a computing paradigm, and that provide paradigm means the way they conclude, they complete their work that involves breaking up a large task into a smaller subtask that can be executed simultaneously on multiple processing unit such as CPU or GPU. In these, we use arithmetical and computation part done by CPU. If we required like video and image processing, we go with the graphical processor unit. Parallel processing aim to increase the speed and efficiency of computation by allowing multiple tasks to be performed in the parallel rather than sequentially. So we ignore the serial part of processing. We don't submit any task one by one. We just put all the tasks in a single way. What is the fundamental of parallel processing? There is use of shared memory parallelism, which means involves multiple processing units sharing a common memory pool, each directly accessing the same data. So we just share our storage pool to all the connected systems. We just have one system for storage. That also called like distributed memory parallelism. Distributed memory parallelism, this involves multiple processing units that do not share memory and must communicate with each other via a network or communication channel. There are some type of ways to achieve the parallel processing. There is other one is hybrid. Hybrid means we can use shared and distributed memory parallelism in the combinedly, that called a hybrid parallelism, combines shared and distributed memory parallelism, and it's commonly used in the large scale computing system. What is the advantage of parallel processing? It is increased speed and efficiency. It is also improve scalability, which called allowing it to handle larger and more complex tasks. Increase fault tolerance. Fault tolerance means any any latches, any failure, it minimize. Whenever we use parallel processing, by the time we don't disturb any task for their required processing, for their required memory, for their required any task. We have much faster system. We just submit our task, it completed at that time. When we use serial processing, we have a limited kind of memory, limited kind of processing power. So that means our processing power is also less. There will we have multiple processor. If one processor fail, then we switch our operation to other processor. That means our entire process not fail. Reduce energy consumption. Parallel processing can reduce energy consumption by executing tasks more quickly and efficiently. What is other use challenges? What is the challenges we are facing for parallel processing? Increased complexity when we use multiple processor in one system. How we can distribute the kind of processing to all these processor, how we use the RAM part, the memory part for all these computer systems. There are some challenges also be there, like increased complexity, communication overheat, distributed memory parallelism. When we distribute memory means we distribute our storage, we distribute our RAM, our secondary storage. It's also depend how it is not risk, like unauthorized access, some other illegal access. any leakage, any memory disturbance. When we connect to any drive, we can't connect at that time. So the communicate part also be coordinated task. Load balancing. Proper load balancing is critical in parallel processing. As uneven distribution of tasks across processing unit can lead to inefficiency and bottlenecking, which means we have multiple tasks at a time, but we don't fulfill every processor by the task. We may be not distributed properly. So the load balancing also be varies on the parallel system. Improve performance. What is the best part to use of this parallel processing? It's improve performance. It's scale our computer system. It's less our fault tolerance. Any kind of fault may be less in the parallel system. We have multiple processor. If one processor may not work, then we switch our processing to other processor. Energy efficiency. So all these benefits we are having, and all these disadvantages we are facing by with the parallel system. What is the applications are working with the parallel processing? Whenever we use big system, like we have multiples load in a website, like a government organization having their servers. So these all servers having the parallel processing, like scientific simulations, all the problems they solve through this scientific purpose, scientific simulation software, they are using parallel processing. Any big data analysis related softwares and machines are performing totally based on the parallel processing. Also, graphic rendering, if we modified any video, audio related software, video, audio related, any rendering, any changes, any performing, they also use parallel processing. Machine learning, AI, cryptography, data management, there are wide section. They are using parallel processing. So we have a problem in this diagram. It is a bulks in size, but we break in small chunks, and also two different processor. It a single problem, we divide in 4, then we divide it each in 5, then we process. That means it's called a parallel processing. We have a big problem, we can break in 4 part. After that, we assign each part in sum of blocks to each processor. There are 4 processors, and after that, we complete this task. That called like a parallel process. What is the examples for the parallel processing? Metric multiplications, image processing, web servers. Web servers we called servers. Like we have social engineering kind of applications like WhatsApp, like other applications where we are submitted. These all big servers called as a web servers. All the website like Google server also having kind of parallel processing. Multiple user at a time accessing the same kind of server with the help of parallel processing. Also cryptography, whenever we use one to one, one from sender, second from receiver, that any part of any country, any area we use to secure the application with the help of parallel processing. What is the parallelism? There are some types of parallelism. One is task parallelism, second one is data parallelism, third one is pipeline parallelism, fourth one is message passing parallelism, fifth one is shared memory parallelism. We just not having only one kind of work for parallelism. Like we have data for processing, we have messaging for processing, we have memory for processing, we have single platform, and we use for our applications multiple tasks for that uh, application. We require data, task, pipeline, message passing, memory. So all these terms, all these type, we can complete our parallelism with the help of these type. We just distributed each part for proper methodology. Who are the popular programming languages are supporting parallel processing, all kind of languages we are just generally learning in this mm, current time, like C, C++, Java, Python, MATLAB. MATLAB also a mathematical related programming language. R programming, C Sharp, also called as a .NET framework, Rust. So all these languages are working with support of parallel processing. There are many different programming languages, each with their own syntax, features, and use cases. Here are few ways in which programming language can be differentiated. So how these programming languages differentiated with their paradigm means the way they are constructing their program with the purpose, how, why they use that language, what is the main feature of that language, what is the syntax, means what is that grammatical system, writing, how the code of that programming language is writing, what is the library, what is the framework, what is the community of that programming languages. So there are some common syntax, some common programming languages are using. You already learn in C languages. C languages has their keywords, their operators, keywords like they use some kind of fixed word for their use. Operator, like we use many sum operator, the arithmetical operator, logical operators. There, there are many operators in the any programming languages. There are variables we use for our programming. There are functions, there are commands, there are control structures like if, else, while, do, while, do. There are many elements, many part of any programming are distributed in some these various keywords. So we learn what the type of the parallelism used in programming. One, we already discussed data. Second one is task. Third one is pipelining. Fourth one is bit level parallelism. Fifth one is instruction level parallelism. I think it's enough for today. Screen settings, stop to share windows is closed. Okay. Okay, we have only one. Okay, so just complete it. After that, we allow you for any discussion point. So what is the data parallelism? This type of parallelism involves dividing a large data set into smaller chunks and processing them concurrently. Whenever we have a big data in size, then we divide it in small chunks and then we complete that task that called as data parallelism. Task parallelism, this type of parallelism involves breaking up a large task into smaller tasks and in subtasks that can be executed concurrently. Pipeline parallelism, these type of parallelism involve breaking up the task into stages that can be executed concurrently. Pipeline means we can decide what kind of task can be completed. After that, which task we complete. So we required some step-by-step process for pipelining for that processing of big tasks. Bit level parallelism. This type of parallelism involve processing multiple bits of data. Bits of data like 0, 1, 2, like any kind of our bit level programming. We use at the same time usually using specialized hardware such as graphical processing unit. Instruction level parallelism. These types of parallelism involve executing multiple instructions at the same time within a single processor code. So we have multiple instructions at that time. We just complete this instruction with the help of the single programming space. All these kind of theories for performing multiple tasks at a time with the help of multiple processor, multiple core processor. So all these things we need to know. What is the parallel processing? What is the serial processing? What we can use with the help of any product we can use with the help of parallel processing. So all this scenario we can complete these two small topics cover in this lecture. If you have any kind of non-understanding part of these lecture, you can ask it through the chat. Please mention your queries in the chat. I will look one after one. So please, anybody, any problem, any topic, any part of this lecture you don't understand, please just write. I will brief you. If you have not have any query, can you tell me about exam paper? It's not these lectures query. So please ask your counselor. I know, but I just brief about there are some MCQs and there are some subjective questions. MCQs means multiple choice questions. So they are must be in 60-40 ratio. You just ask your counselor, Ritika. I don't know what is the name of counselor, but I will also share their problem. They will inform you all these queries in your WhatsApp group. So don't worry about that. So for today, I conclude this session. Okay. Have a good day, all. Panga sir. Okay, Kritika. I just confirm on that. I will reply in next class. What is the pattern of your exam? So don't worry. And I also share all kind of information through your WhatsApp. So don't worry about that. One second, Kritika. Just confirming. वाया व्हाट्सएप में आपको ये जो डिटेल्स है वो जो भी एसएमईज है जो भी आपका जो व्हाट्सएप फोन कंट्रोल करता है एलएमएस मैनेजर के थ्रू आपको ये इंफॉर्मेशन कन्वे करवाता हूँ। ओके, कंफर्म करके आपको व्हाट्सएप के थ्रू कंप्लीट करवाता हूँ। ठीक है, ओके, बाय।